Today, we're going to start our journey into statistics. And we're going to start with sampling, what it really means to have a sample. So, statistics is the study of procedures for collecting, describing, and drawing conclusions from information. I can't think of any job in the world where you don't have to collect some kind of information and describe the information you collected and draw some kind of conclusions from it. Now, when we're talking about collecting data, a population is the entire collection of individuals about which information is sought. And a sample is a subset of that population. Those are the people we actually observe or survey or get the data from. Now, when we're selecting a sample, a simple random sample of size n. That means it's a sample chosen by a method in which each collection of a certain number of population items is equally likely to make up the sample. It is analogous to a lottery. Let's say 10,000 lottery tickets are sold and 5 are drawn as the winning tickets. Each collection of 5 tickets that can be formed is equally likely to make up the group of 5 that is drawn as winning tickets. A physical education professor wants to study the physical fitness levels of 20,000 students enrolled at our university. She obtains a list of all 20,000 students, numbered from 1 to 20,000, and uses a computer random number generator to generate 100 random integers between 1 and 20,000. Then invites the 100 students corresponding to those numbers to participate in the study. Is this a simple random sample? Well, does each student, are they equally likely to be picked if the computer is doing a random number generator? Well, yes. Each student is equally likely to be in the sample. Everybody has the same chance of being in the sample. Now, let's say the professor in the last example now wants to draw a sample of 50 students to fill out a questionnaire about which sports they play. The professor's 10 a.m. class has 50 students. She uses the first 20 minutes of class to have the students fill out the questionnaire. Is this a simple random sample? Well, no. Only the students in that class were chosen. What about the other 19,000 students? They didn't have a chance to participate. So that is not a simple random sample. Now, in some cases, it is difficult or impossible to draw a sample in a truly random way. In these cases, the best one can do is to sample items by some convenient method. A sample of convenience is a sample that is not drawn by a well-defined random method. Let's look at an example. A construction engineer has just received a shipment of 1,000 concrete blocks. The blocks have been delivered in a large pile. An engineer wishes to investigate the crushing strength of the blocks by measuring the strengths in a sample of 10 blocks. Explain why it might be difficult to draw a simple random sample of blocks. Well, just the weight of the blocks alone would cause an issue. The weight of the blocks makes the task very difficult. Think about if you were trying to do a truly random, then something from the center of the pile would have an equal opportunity as something on the outside edges. But that would be very, very hard to do. Now, the problem with samples of convenience is that they may differ systematically in some way from the population. If it is reasonable to believe that no important systematic differences exist, then it is acceptable to treat the sample of convenience as if it were a simple random sample. But in the case of like those students that took the 10 a.m. class, do they truly reflect the entire population or just that group of students? Okay, now there's other ways we can draw a sample. So we're going to talk about some other methods. One of them is called a stratified random sampling. In this, the population is divided up into groups called strata. Then a simple random sample is drawn from each stratum. Stratified sampling is useful when the strata differ from one another, but the individuals within a stratum tend to be alike. So let's say a company has 800 full-time and 200 part-time employees. To draw a sample of 100 employees, a simple random sample of 80 full-time and 20 part-time are selected because you want to have the same percentage of full-time as you do part-time. Another example is when we have I just realized my pictures are mixed up and I already made these copies. Drawing from the full-time and the part-time employees, that's down here. That's the stratified sample. Another reason you might want to do a stratified sample is, let's say I wanted to have an equal number of men and women within the sample, or an equal representation of gender, I just said gender, or race, or education, and so forth. I can't believe I mixed up my pictures. In a cluster sampling, items are drawn from the population in groups or clusters. Cluster sampling is useful when the population is too large and spread out. So an example of that is when you take all the households in the world or in the United States, and we take a random sample of whole households. These clusters become our sample. So instead of randomly sampling a person from each household, the whole household is selected. So this is clusters. A whole cluster or a whole classroom is selected. Now the next one makes a lot more sense. Systematic sampling. In systematic sampling, items are ordered, like numbered, and every kth item, so maybe every 5th person or every 10th person is chosen to be included in the sample. Systematic sampling is sometimes used to sample products as they come off an assembly line. So let's say automobiles are coming off an assembly line. it is decided to draw a systematic sample for a detailed check of the steering system. The starting point will be the third car. Then every fifth car after that will be sampled. So which cars will be sampled? So we'd start with car number 3, and then every fifth one after that. So car number 3, number 8, so number 3, number 8, 5 cars later would be 13, then 18, and so forth. Voluntary response sampling. This is used a lot by the media to try to engage the audience. For example, a radio announcer will invite people to call the station to say what they think about something. Voluntary response samples are never reliable for the following reasons. People who volunteer an opinion tend to have stronger opinions than is typical of the population. If they are willing to call that radio station or to fill out that survey, then they have an opinion about it. They have a strong opinion about it. Also, people with negative opinions are often more likely to volunteer a response. You'll notice that on social media. You see a lot more negative comments than you do positives, because people who are upset tend to want to voice their opinions. Now we want to talk a little bit more about vocabulary. The difference between statistics and what are called parameters. A statistic is a number that describes a sample. It's what we got from the sample. It summarizes what we learned from the sample. A parameter is that same number, but describing the population. So let's see if we can see the difference here. Let's say 57% of the teachers at Central High School are female. Is that a statistic or a parameter? Well, it's a parameter because it describes the population of the high school. In the next example, in a sample of 100 surgery patients, keyword sample, who were given a new pain reliever, 78% of them reported significant pain relief. So notice this is coming from a sample. That's a statistic. And that's because it came from a sample. You will always notice those words from a sample, from the survey. You will always get some key word that tells you it came from the sample.